Hello guys, welcome back to my channel again. Today I'm very much excited to bring you yet another thing, and this thing I'm bringing to you today is about nucleon interactions in the nucleus. Last time, in the last episode, we did weak force. Now today we are going to explore about the nucleon interactions in the nucleus, and this is about how does a nucleon interact with others inside a nucleus. Okay, so just let's go on. Nuclear forces, also known as nuclear interactions or strong forces. So here today we are talking about strong forces. Remember, we were talking about weak forces. Now today we are talking about strong forces. So nuclear forces are the forces that act between two or more nucleons. Okay. If you don't know what nucleons is, please go back to the other video and then come to this one. So they bind protons and neutrons. That's nucleons. Actually, they have told you here. Nucleons are made from protons and neutrons. So this force, strong force, bind protons and neutrons together into atomic nuclei. Okay, so the nuclear force is about 10 million times stronger than the chemical binding that holds atoms together in a molecule. It's 10 million times stronger. Just think about it. So look, here's a situation. You know what an atom is. An atom is made of neutron, electron and proton, right? And it's held together by this nuclear force, which is 10 times stronger. The nuclear force is about 10 million times stronger than the chemical binding that holds atoms together in a molecule. So here we have atoms in a molecule, and we have the nuclear force that holds these protons and neutrons into atomic nuclei. Okay, so it's 10 million times stronger. I'm repeating that. Now that's said. What is the interaction in the nuclear process? What is the interaction? Most of the interactions involve changes in the interacting masses, namely the emission and absorption, okay, of massless objects, protons and neutrons. So it means these proton and neutrons are not so massless as I described here. Now the weak interaction involves, now that's what we did previously, the weak interaction involves a change in mass and at the same time a change in charge. Electrons, muons, or tau particle emission or absorption. Okay. So that's what it is. What is interaction? We're talking of nuclear interaction. Yeah. So let's go on. What interaction occurs in the nucleus of an atom? What interaction occurs there? In a nucleus, the strong nuclear force causes interactions between protons and protons, between neutrons and neutrons, and between protons and neutrons. So you can see what that means in a nucleus. So there's a lot going on. There's interactions between protons alone, and you know, protons are like, they're like, if you talk about how do they come together actually, why don't they rebel? They must be having electromagnetic sim here, like balls rebel and like balls attract. So how come protons don't repel each other? Because of this strong nuclear force. I suppose it's more stronger than electromagnetic force, so that it can actually bind them together despite the fact that they're rebelling each other. Because here we have also electrons around these interactions. So we have protons, neutrons and electrons. And then we have interactions between neutrons and neutrons. So how do they interact? These are like particles, they are like particles, right? And I think the neutrons weighs more than a proton in terms of mass. Okay, we are not talking about mass, but about interaction. How do they interact? How do they repel each other? Do they attract each other inside the nucleus? But because of the nuclear force that binds them together, 10 million times stronger than the chemical bonding of atoms in molecule, maybe they stick together. And then there's an interaction between protons and neutrons. This one is okay because they're different. You can suppose that maybe they pull each other together. So a lot goes inside the nucleus, right? I'm trying to get more materials that I put down here. So what are the two forces acting on nucleon, on atoms? That one you've said, but we can repeat it again. What are the two forces acting on a nuclear in atoms? You have electric forces. Okay, this is what I was telling you before. Actually I was guessing it, but I was right. Here it is. Electric forces try to break the nucleus apart. Electromagnetism, right? Because they rebel. If proton and proton are put together, they are going to repel each other. Now, but because while the strong nuclear force tries to bind the nucleus together, okay, exactly what I told you. When these electrons are trying to break apart or tear apart, or the neutrons, now the strong nuclear force binds them together because it's 10 times million stronger than than the binding force between atoms, which makes up a molecule. In larger atoms, which means they are larger ones, the electric force of repulsion, exactly, the electric force of repulsion may break the nucleus apart. So you get it? Resulting in a form of radiation called alpha decay. So if it's large, the atom gets large, it becomes unstable, and it will undergo something called alpha decay. Alpha decay, because the reason given here is that in a larger atoms, the electric force of repulsion may break the nucleus apart. Now, if that happens, it will result in a form of radiation called alpha decay, sorry. And what is decay? Decay is when it loses some energy. Radiation is radiation. Radiation means it's losing energy so that it becomes stable. Because it's large, it loses some energy, then it becomes stable. And that process is called alpha decay. And this we have said about it. What are the two? Actually, it's like questions I'm putting out and answering them at the same time. What are the two main forces that interact in nucleus? We have the strong nuclear force. It is an attractive force between protons and neutrons that keep the nucleus together, and the weak nuclear force is responsible for the radioactive decay of certain nuclei. So actually when decay takes place, you can blame that on the weak nuclear interaction, nuclear force. And then when it's being bound together, that's due to the strong nuclear force. So this is about interaction. We talked about interaction, and this is what it is. I'm trying to see whether there's anything else for you guys. So yeah, that's about it. I think we'll continue and we'll talk about the radioactivity. So we're going down about this nuclear thing. And we know from the previous videos what nuclear is made of: protons, neutrons, the atom, and inside the atom we have the protons, neutrons, and electrons, and the nucleon, which comes from nuclear and neutrons and protons binding together to form a nucleon. Now this situation is describing what happens inside the nucleus, what happens inside the nucleus. So you see, we're going deep down to the nucleus level. So yeah, so we'll continue about this, and please go back to the previous video about the weak force and read about it, or play it once more to get some idea about these interactions, nucleon interaction, the nucleus, because the nucleon is made out of protons and neutrons. Okay guys, and maybe if you don't know what nucleons are, I can refresh your memory. Protons and neutrons are nucleons. Together they make up the atomic nucleus. So this is the nucleus. When you are saying what is happening inside the nucleus is made out of protons and neutrons, which are nucleons, and together they make up the atomic nucleus. Now, from the previous video, we have said that in chemistry and physics, a nucleon is a proton or a neutron in the atomic nucleus. And in contrast, there are free protons and neutrons. I'm repeating the other video, which are not considered to be nucleons. Now, protons have a net positive electric charge, while neutrons are electrically neutral. So nucleons in an atomic nucleus have a net positive charge. So actually the nucleons that I'm talking about interaction, they have a charge. They are not neutral, and they are made from protons and neutrons, and they have a charge. So like for example, when you say that neutrons are electrically neutral, but this is not neutrons, these are nucleons, because which has been formed as a result of protons and neutrons combining, and these nucleons have a charge. So because of the charge, I think that's why the interaction takes place. They are not neutral. So we talk about alpha particle, that's the decay. Now we talk about beta particle in the next video. Okay. Or rather, yeah, I can take it further. What does decay mean in physics? That one I've told you already in the other video. I'm refreshing your memory. Radioactive decay is the random process in which a nucleus loses energy by emitting radiation. This is usually in the form of alpha particles, that's helium nuclei, alpha particles, and beta particles, electrons or positrons, all gamma rays, high energy photons. The nucleus energy reduces, making it more stable. So guys, I'm just repeating the other video. I think that if you go to the other video, you about the weak force. You learn all this. If you have not watched it, want to watch it. So for today, I think I'll end this about the interactions here, and we continue on the radioactive of the nucleus. So as we try to explore what the nucleus is, the alpha particles, the beta particles, the quarks thing. When you say the quarks, the muons, the gluons, the mesons, Higgs bosons. We want to go down to the fields. The universe is made of the fields, virtual particles. How do they come into be from nothing? This is where we are heading. Okay guys, stay tuned to my channel. Please like and share and subscribe and comment about this. You remember, you are made of electrons. You who is watching this video, you contain these particles that I'm describing to you. You are made out of these electrons, and the electrons makes up the universe as a fluid field. It's a field. So if you go to the field level, you are interacting with these fields. They pass right through you and interact with them. You're not aware of that, and you are an excitation, like in the sea, where you see all of a sudden the water rises, like forms something, a certain kind of wave excitation. It comes up, you pop up, right? If in like a quanta out of this, and then you seamlessly go there. We are all connected with the universe. I don't know whether this is what entanglement is about. We've not talked on that yet, so please, let's end it here. We're going far. Thanks for watching. Please like, share and subscribe and comment to my channel. Again, I repeat that, please subscribe to my channel. If you find substance in what I'm telling you, please subscribe, because by subscribing you are supporting me to continue with this content. Bye for now. Bye.